Thanks for joining me in today's lesson. In this first tutorial, we will solve simple exponential equations. So we are in section 4.6 in our textbook, and we're looking at the simple version of exponential equations. That means that we can use this property. If we have base a raised to the x power, and that is equal to the same base a raised to the y power, of course this statement can only be true if and only if x and y are equal. So this is a pretty simple property to understand. And if we can rewrite an exponential equation using the same base on both sides, then the bases become irrelevant and we can set the exponents equal to themselves. And then we have a little equation to solve. If we're not able to do that, then we're going to need the more complex exponential equation techniques. But that's in a future tutorial. So let's look at example number 1. I have 3 raised to the x plus 1 power, and that is equal to 81. Well, 81 is not just some random number. I also know 81 as 9 squared. It's a perfect square. That doesn't really help me to write it as a base 9, though, since I'm using base 3 on this left side. I also know that 81 is 3 to the 4th power. So if I write the left side, well, actually, I don't do anything to the left side. 3 to the x plus 1 stays the same, but the right side turns to 3 to the 4th power. Then I have written both sides using the same base, base 3. And therefore, according to the property, I don't really need the bases. I can just equate the exponents. So these 3's, as long as they're the same, basically become irrelevant, and I have that x plus 1 has to equal 4, which of course means that x equals 3. That's a very simple way of solving this exponential equation. Looking at example 2, we got a few more things going on. I see a base 2, I see a base 8, I see a base 4. And if I need to rewrite them all using the same base, I probably have to choose the smallest of those numbers, which is 2. So I'll go ahead and leave 2 to the x power alone. 8, I'm going to need to rewrite as a base 2. So hopefully you know that 8, of course, is 2 cubed. So I'm going to change the 8. I'm not going to change it. I'm just going to rewrite what it looks like. Instead of 8, I'm going to write 2 cubed. It's still raised to the negative x power. And then 4, if I need to write it as base 2, we all know that 4 is 2 squared. So I'm going to change the 4, at least what it looks like, to 2 squared. And then it's still to the 3x plus 1 power. So at least now I've written everything in terms of base 2, but I cannot use this property yet until I have exactly one power on one side and one power on the other. So I've got some laws of exponents to do. I've got the product power here. I need to multiply those two exponents. So this is going to become 2 to the negative 3x. Same thing here, I'm going to be multiplying these two exponents. This is like a power to a power. So I need to distribute this 2 to the 3x, so it makes 6x, and the 2 to the 1, of course, makes 2. I'm not yet able to use the property still because I need to put these two things together. As long as they are the same bases, I can multiply them by adding the exponents. So I have 2 to the negative 2x. And then over here I have 2 to the 6x plus 2. So we had to do a little bit of algebra first, and now I can see that I do have the same bases on both sides, one term equal one term, so therefore the bases become irrelevant and the exponents must be equal. And now I just need to solve this equation and I'll be finished. So I'll probably subtract the 6x over to here and get negative 8x. And then I'll divide both sides by negative 8 and reduce, and I'll have negative 1/4. Excellent. And our final example, I've got 1/5, that's my first base, and I have square root of 5. So I need to figure out what I'm going to do here. I know that 1/5 can be written as base 5, and I think that that's the number that I'm going to be shooting for, so I see the 5's. 1/5 is the same thing as 5 to the negative 1 power. Remember, negative exponents make reciprocals of the bases. So if I see a fraction, I can write it as a negative exponent. Still raised to the x plus 4. And then I have this radical, and remind yourself that radicals are the radicand to a fraction exponent. Since it's a square root, I have the 1/2 power. If it were the cube root, it would be the 1/3 power. So that's good. I have both of them in terms of base 5. I probably am going to do a little bit more work here. Multiplying these exponents, I get 5 to the negative x minus 4. It's like a distribution here. And of course, this will stay 5 to the 1/2. And now that I have the 5 to a power equals the 5 to a power, the 5's become irrelevant. The exponents must be equal. And there's my equation. I just need to solve for x. I'll add 4. So I have negative x is equal to, I've got 1/2 plus 4. Well, that's the same thing as 4.5, I guess. I don't really like decimals, so I might change that to 9/2. And then, of course, making positive x would be equal to negative 9/2. So that's a technique to solving simple exponential equations if you can rewrite things using the same base. And I'd like for you to look for those simple equations. We'll practice this more in class. Thanks for watching this quick tutorial. Oh, thank you. You're very kind. See ya.